Good morning, one and all. Today we are doing the third experiment of Theodolite survey. So, experiment number 3, that is to determine the height of a building using Theodolite. So, already we have discussed the parts of a Theodolite. There is a tripod, then leveling head. Leveling head consists of an upper triangular plate, and that is called as tribrac, and the lower plate is called as trivet plate. Then there is an optical plummet. This is the optical plummet. Using this it is possible to see the center point of the instrument on the ground. So that is optical plummet. Then horizontal circle, vertical circle. Then also there is an upper clamping screw, tangent screw, lower clamping screw, tangent screw, and there are A and B verniers on the horizontal circle. So the instrument can be rotated about the vertical axis. Then there is a vertical circle, A frame is there, then focusing screw, telescope, objective, then vertical circle clamping screw. Now this is the eyepiece. Eyepiece screw can be turned in and out for adjusting the crosshair, and for this screw is called as a focusing screw, and that is for eliminating the parallax by focusing the objective. Okay. Now today we are going to determine the height of a building using total station. So to determine the height, we need to take two vertical angles. One is angle of elevation sighting to the top of the building, and the other one is the angle of depression sighting to the bottom of the building, whose height is to be determined. So first you keep the instrument at a particular point, do the temporary adjustments like setting up leveling, elimination of parallax, etc. And after that now do the leveling with respect to the altitude bubble also. Here you can see the altitude level too. Okay. Now after that you have to set 0 in the vertical circle. So this is the vertical circle and you have to set 0. Set 0 means what? The C and D verniers. This is C and the other one is D. So C and D should be 0 degree. So when the telescope is horizontal, line of sight will be horizontal, and the C and D will be, readings will be 0. So here there is a main scale. In the main scale it is 0 to 90 degrees there, and in the vernier scale, so vernier scale 0 to 20 minutes is there. So here you can see the letter C, and the 0 of the C should coincide with the, so C എന്ന് എഴുതിയിരിക്കുന്നത് മെയിൻ സ്കെയിലാണ്. ഓക്കെ, വെർനിയർ സ്കെയിലാണ്. അപ്പോൾ 0 of the vernier should coincide with the 0 of the main scale. Similarly, at the opposite, diametrically opposite end, the 0 of the D should coincide with the 0 of the main scale, should coincide with that of the vernier. Now this is the first step. You have to set the instrument. Then after setting 0, unclamp the vertical circle clamping screw, turn the telescope and sight to the top of the building. You will get the angle from vernier C. Also take the angle from vernier D. You will get the angle which the line of sight makes with the line connecting the instrument at the top of the building. Okay, so let's note down that angle. Similarly, in the next step, what you have to do? You have to sight to the bottom of the building. So you have to unclamp the vertical circle clamping screw, turn the telescope and sight to the bottom of the building. After that you will get an angle, so that will be angle of depression. So note it down. Now first you have to do this in the left face right swing. So left face means the vertical circle should be to the left of the observer. So here you can see that the vertical circle is to the left of the observer. You are loosening the vertical circle clamping screw and you are sighting to the top of the, you are turning the telescope and you are sighting, and when the crosshair, that is the horizontal crosshair, exactly bisects the top portion of the building, you have to clamp the vertical circle clamping screw. And after that, there is a tangent screw provided, so that I think it is very difficult to see, but to certain extent you can see through the telescope. You have to sight the top of the building. Now for fine adjustments, you can use this vertical circle you can use this vertical circle tangent screw for fine adjustments. Now after that, note down the reading and then again loosen the vertical circle clamping screw and turn the telescope and sight to the bottom. So again you will get an angle, so that will be angle of depression, and you have to note it down. Similarly, change the face to right face, and again you have to repeat the procedure. Sight to the top, note down the reading. Sight to the bottom, note down the reading. Okay, so this is the procedure for taking vertical angles using theodolite.